welcome to Diksha Vedantu YouTube channel. I hope you all are doing great. I know you all are a bit stressed about your pre-boards and boards, so we at Diksha Vedantu has brought you a rapid revision series specifically to target your pre-boards and boards. So I'm Aditi, your very own physics faculty, and today I'm back with yet again rapid revision chapter for light. Yes, now we all know it's a really important chapter. Every year at least one 5 marks or 3 marks question has been asked continuously. So sit back and relax, because today we are going to cover the whole chapter and we'll try to cover it in just 25-30 minutes so that you have plenty of time to revise. Let's start the chapter. The chapter of course starts with, ma'am, what is light? Light is a form of energy that lets us see this beautiful world around us. And we know a very important fact about light, that it has dual nature. It can act as a particle and it can act as a wave. It can change its behavior according to the situation, as a particle, as a wave. Moving on, next is, why do we see objects? Because the main motive of this chapter is, why do we see objects depends on why do we see objects. We see objects because of a very important phenomena which is called reflection. Of course, right? Light hits a surface or hits an object and it bounces back and it reflects back and hits our eyes, and hence we can see the object. Then we'll see what are the laws of reflection. Ma'am, we know laws of reflection. We have mixed it in a jadi booty and drank it. The angle of incidence is always equal to the angle of reflection. The incident ray, the normal to the mirror. The incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. And then we have two types of spherical mirrors that we are going to study in this chapter in real depth, which is what? One is concave mirror. The other one is convex mirror. Very good. You should remember their shape. Concave mirror is like you are going inside a cave and the other side is reflecting. This is our focus. This is our center of curvature. This is our pole. This is the aperture of the mirror. What else is left? That is done. And then convex mirror, we also know what kind of shape does convex mirror have? Thus the opposite. Now here the outer part is reflecting and the inner part is non-reflecting, and in this we have focus on this side and hence the center of curvature a bit behind, and rays come from this side. Of course, that is done. One more thing to remember, our concave mirror is a converging mirror. It is a converging mirror, and hence convex mirror is a diverging mirror. Why? Because when the rays come, it converges them to at a point, but when rays come and hit the convex mirror, it does not converge them at a point, it diverges them. It just appears that it's coming from a point called focus. Next topic is, where is it? Yeah. Okay, next topic is our ray diagrams. Ma'am, we are stuck at ray diagrams. Let me just revise it first. What are the 6 cases of concave mirror? And I'll give you a very important trick this time. Okay, the first case is when the rays are coming from infinity. Rays are coming from infinity, and mostly from infinity, as well as if they're parallel to the principal axis, they will reflect, converge back at the focus. Correct. Second case is when our object is beyond C. Where is it? Beyond C, center of curvature. A ray will come parallel to the principal axis, pass through the focus. Another ray will pass from the center of curvature, reflects, hits the mirror, reflects back and follows the same path. Why? Because it's passing from center of curvature. Very good. So the image formed here is small. We need to remember, in concave mirror the image is real. Why? Because actual rays are meeting, so real rays are meeting, so the image is real, and it's inverted, and in this case it is diminished as well. diminished. Correct. Then the next case, now we move the object a bit towards the concave mirror. Here it was infinity, we brought it towards the mirror, close to the mirror, now it's at beyond C. Then again a bit more close to the mirror, now it is at center of curvature. Again one ray comes parallel, pass from focus, another ray goes from the focus. Now it is at center of curvature, so the ray can't pass from the center of curvature, so it passes from focus, and we know the ray passing from focus hits the mirror and goes back to infinity parallel to principal axis. So in this case our image is made at the exact point where our object is, which is center of curvature. Again the image is real and the image is inverted, and in this case our image is of same size as of our object. Now next case. Now we move the image a bit more close to the mirror, so it's between C and center of curvature and focus. A ray comes parallel, pass from focus, another ray goes from the focus, gets parallel to the principal axis, and this is where our image will be formed. It will be real, it will be inverted, and in this case it will be enlarged. What is it? Enlarged. See, as the object is getting closer, the image is getting far away from the mirror, and it's also increasing in size. Here it was point size, here it was diminished, here it was of same size, now it is enlarged, and in here now we brought our object more close towards the mirror, so it is at focus. What's happening? One ray parallel to the focus. Again, if now our object is at the focus, rays cannot pass from the focus, so here we use fourth law, which is if our ray hits the pole of the mirror, it reflects back at the same angle. Now these rays are parallel, which goes till infinity, so our image is formed at infinity when the object is at focus. Again real, inverted, and extra enlarged, extra large images formed in this case. Then these 5 cases we know: real, inverted, and then of different sizes: point size, same size, point size diminished, same size, enlarged, extra large. Now this is our 6th case, which is an exception. When this is not the focus will be here. When our object is between focus and pole, so what will happen? The ray 1 will go till here and will pass through the it will pass from our focus. This will not be, this is not our focus. Okay, this is not our focus, the focus will somewhere be here. So if my object is between focus and pole, it will hit the mirror parallelly and the ray will pass from the focus, and another ray will pass from the center of curvature. It will go here and come back and pass through the center of curvature. So we'll extend these rays back, and the point where it meets is where our image will be formed. In this case our image is virtual. What is it? Virtual. Why? Because real rays are not meeting, it is just appearing to us that they are meeting behind the mirror. Virtual, erect, and it is large. Obviously we can see it, and hence ray diagrams for concave mirror are done. Moving to convex mirror, we just have 2 cases. First case, if the rays are coming from infinity, now this does not converge, its focus is behind the mirror. This mirror diverges these rays and it appears to us that it is coming from a point which is our focus. Then another case, this is just random case, anywhere on the principal axis. We studied that it is beyond C in concave mirror, beyond C, at C, between C and F, blah blah. In this case we just have only one case, anywhere on the principal axis. So this is our object and rays are coming where it will diverge and it appears to us that it is coming from focus. The other ray goes and it appears to us that it's passing through center of curvature. Please make these rays with a scale. Center of curvature, and it goes back the same direction. Now this is where the rays are meeting and this is our object. In this case our image is always virtual, it is always erect, and it is always diminished in the case of convex mirror. Virtual, erect, diminished, convex mirror. Real, inverted, of different sizes, concave mirror. Okay, these are the sign conventions that we need for our numericals, which are very important for left hand side. Okay, this is, let's say, my concave mirror. Okay, and this is pole. This is our left hand side, this is our right hand side. If it's on the left hand side, it's negative. Distance is negative. Right hand side, positive. Upper side of the principal axis, positive. Downside of the principal axis, negative. Here, height above the principal axis, positive. Below the principal axis, negative. U distance, our distance of object, is always negative for image if it's real and inverted. When it's real and inverted, it was forming on left hand side, so it's negative. If virtual and erect, it was forming on right hand side, so it's positive. Focal length of concave mirror, we know, is always negative. Focal length of convex mirror, which is like this, yes, this is always on the right hand side, so focal length is always positive, thus radius of curvature is positive. Focal length for concave mirror is on this side, so it's negative, and radius of curvature is also negative. Oof, we just completed reflection in how much time? Okay, 11 minutes. That's good. Okay, so image formed by concave mirror. Yes, image formed by concave mirror was real as well as virtual. It was both. Remember the sixth case, right? And 1 to 5 cases. Then it was always inverted in case of real, and it was erect in case of virtual, and it was of different sizes. Point size, then it was diminished, then it was same size, then it was large, then extra large, and all, and in here it was large. Correct? For convex, comment down what kind of image does a convex mirror makes. Was it real or virtual? Was it diminished or enlarged or same size? And was it inverted or erect? Come on, comment down as quickly as possible. See the timestamp, 12:38. Write your timestamp and comment down. Okay, moving on to the next, mirror formula. It's just one thing which is very important for our numericals, mirror formula and magnification. What is mirror formula? 1 by f. F is focal length, and 1 by v plus 1 by u. Remember these signs, 1 by f plus 1 by f equals to 1 by v plus 1 by u. This is our mirror formula. What is magnification? Magnification, ma'am, is it's minus negative of v by u. Also, it is height of image by height of object. Very good. Moving on, we have already covered reflection. Let's move to refraction. Refraction is what? Bending of light when it passes from one medium to the another. When light travels from one medium, let's say air, to the water, it bends towards the normal. Why? Because it's going from rarer to denser, and if it's bending from away from the normal, then it's moving from denser to rarer. Let's just see this. This is my rarer medium, this is my denser medium, this is my normal. Incident ray is coming and it's making angle I. If now the medium is denser, so it will bend, instead of going straight like this, it will bend towards the normal, and this is our angle of refraction. Okay, and if my this is denser and this is rarer medium, what will happen? The incident ray coming, this is making angle I. Instead of bending towards the normal or going straight, it bends away from the normal, and this whole angle with the normal is called our angle of refraction. Very good. Again, just like we had laws of reflection, we have laws of refraction. This does not say that angle of incident and angle of refraction are same. We just saw, right? It's bending, so angles are not same. In this, they say that first is the same. Incident ray, the refracted ray, the incident ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. This is same. For the other law, where for reflection it was angle of incidence equal to angle of reflection, here it is angle the ratio of sine of angle, ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the angle sine of angle of refraction is a constant for the given light of a given color and for the given pair of media. What they're saying is, for air and water, this sine I by sine R, if light is going from air to water, the sine I and sine R will be constant. But if it's going from air to, let's say, your fruity, okay, it's going till into fruity, so our sine I and sine R still will be constant, but these two constant will not be same. These are different. This is what is written, right? For given pair of media, these are constant for the given light of a given color for the given pair of media. And it's also called Snell's law. Remember this name, Snell's law. They can directly ask you in the paper what is Snell's law. So you just have to write this formula, sine I by sine R equals to constant, and you can write this definition where you definitely have to write for the given for the light of a given color and for the given pair of media. Let's move on to the next. Now we studied what is refractive index. So when the light is bending, when the light is passing from one media to another, we know it's bending. The extent of bending it goes, that depends on the refractive index of our medium. So the extent of change in the direction of the extent of change in the direction of ray of light that takes place in a given pair of media, again expressed in terms of refractive index. When my light is going from air into the water, so this is my angle of incidence. Now V1 is the speed of light in air, or my first medium, V1 first medium, and then V2 in second medium, and in here the second medium we have taken is water, and this is again our angle of incidence, angle of refraction, our normal, point of incidence and all. So refractive index is equal to, what is it? The speed of light in first medium, by the ratio of speed of light in second medium. But will this be equal to n12 or will this be equal to n21? It is equal to n21. This is always proportional. N21 will be equal to, first we will write 1, V1 divided by V2. If it was N12, then it will be V2 divided by V1. And this N12 means the refractive index of medium 1 with respect to medium 2. And in here it means the refractive index of medium 2 with respect to medium 1. See, N21 be the refractive index. This is N21. This is the refractive index of medium 2 with respect to medium 1, correct? And V1 the speed of light in medium 1, V2 the speed of light in medium 2. We're done with the refractive index. Let's move to the refraction from a glass slab. Now we studied refraction, we studied the laws, we studied the refractive index. Let's apply it to a real life application, let's say. So we have a glass slab. Okay, this is air, this is the first medium, then it entered into our glass slab, and again it comes out into the air. So our incident ray is going, it's hitting this point of incidence, it bends towards the normal, since obviously glass's refractive index is more than refractive index of air. So it bends towards the normal, and now so here it was going from rarer to denser, but now it's going from denser to rarer. So it will bend away from the normal. So this is away from the normal. Correct? You can clearly see it. If I extend the path of incident ray, if it wouldn't have gone under refraction, this will be its original path. So we saw that this path, this incident ray and this emergent ray are parallel to each other and the distance between them, this d is called lateral displacement. T is called lateral displacement. I is angle of incidence, angle of refraction, and when it comes out from denser to rarer, this angle is called, it emerges out from air, from glass to the air, so it's called angle of emergence. Okay, now we studied reflection, ray diagrams in reflection. We'll study ray diagrams in refraction as well. We have two kind of lenses. Yes, we have two lenses in refraction. One is concave lens as well as one is convex lens. This is just the opposite of the mirrors. In mirrors, the properties and the kind of image concave mirror was making, here convex lens will same kind of image, and the convex mirror was making such kind of images will be made by concave lens in refraction. Let's study about so we had 6 cases for concave mirror. Now we'll have 6 cases for convex lens. This is wrong. This will be convex lens, not concave mirror. Okay, first case was coming parallel, converges, and hence this is our first case. The rays are coming parallel and thus it why does it, okay, the rays are coming parallel and the rays are coming parallel and hence they are then converging, they are getting refracted from the lens and they are converging at the focus. Very good. Okay, this is our focus. Now in lens, this is not called center of curvature, or was I not in the frame? Okay, this was f1, this will be f2, which is our center of radius of curvature in mirror. This is f2 and then this will be 2f2. This is f1 and 2f. This will be 2f1. Okay, see here 2f1, f1, f2, 2f2. Now we brought the object closer to the lens. This is beyond 2f2. So again one ray will come parallel, pass from focus. Again the other ray here, it's passing from optical center. It passes from optical center and goes straight without any refraction. In here the image is also being made real, inverted, and in this case it is a bit what is it? Yes, a bit small. Okay, then the third case, now the image is at 2f1. The same we had, right? The image was beyond C, here it is beyond 2f2. Here there in mirror it was at C, here it was at 2f1. So the ray are coming parallel, passing from focus, going from optical center without any refraction. Here our image will be formed at 2f2. Again the image will be real, inverted, and same size. Okay, the object is at 2f1, the image is at 2f2. Okay, the fourth case we have when we brought the object a little more closer. If this goes in, okay, it is between 2f1 and f1 now. So this is our object. One ray then again comes parallel, passes through focus, then optical center, it passes through optical center without any refraction. So the object made is real, again it's inverted and it's large in size. Very good. Next, fifth case. Now we have brought the object more closer to lens. Now it is at our focus f1. A ray goes parallel into the focus. Now you must have crammed it with your heart. Okay, passes from optical center. So the image is now at f1. One ray will come parallel to the lens, another will pass directly from the optical center, and in this case our image will be forming at infinity. Again the image will be real, it will be inverted, and it will be extra large. Okay, again just like we had a sixth case in concave mirror, which was an exception, our sixth case in convex lens will also be an exception. In here we know the image will be virtual, erect, and it will be large, just like concave mirror. But how? It is between optical center and f1. Now the one ray will go parallel and it will pass to the focus, another will go from the optical center, and it will appear to us that they're coming from back because they are not meeting anywhere here. Okay, they are growing apart, so the image will form behind 2f1, which will be large, virtual, and erect. Moving on to the next. Okay, next lens is our concave lens. Again, this is concave lens. Just like we just had two cases in convex mirror, here we have two cases for convex lens. One is the rays are coming parallel and they are diverging, they are converging back. In this case, no, they are diverging and they are appearing to us that they are converging back to the focus, which is the exact same case as convex mirror. And the second case is again anywhere on our axis. Here we have placed the object between 2f2 and f1. One ray goes back, it diverges, meets behind at f1. Again another goes from the optical center, and this is where the rays are meeting. So it's between optical center and f1. In this case, which is concave lens, the image will also be again virtual, erect, and diminished. Very good. We are done with our lenses also. Just we have one more topic left. Before that, we'll see the sign conventions. It is almost the same. This is our concave lens. This is our convex lens. For concave lens and concave mirror, focal length will always be negative. Hence, the radius of curvature will always be negative. And for convex lens and convex mirror, focal length will always be positive. Thus, radius of curvature will also be positive. And above the principal axis positive, down the principal axis negative, on the left hand side negative, right hand side positive. Everything is same except the distance of image. In that case, for virtual and erect, we were taking image distance as positive. In case of lens, for virtual and erect, we will take the distance as negative, and for real and inverted, we will take positive. For virtual and erect, it will be negative. And lens formula, just like we had mirror formula, there is only one difference, which is 1 by v. There we had plus 1 by u, here it will be minus 1 by u. And for magnification, the height of image by height of object. But now in this, it won't be minus v by u, it will be plus v by u. And hence, for concave lens and convex lens, comment down what is the magnification. You know it's negative for real and inverted, and positive for, it will be positive for real and inverted, and negative for virtual and erect. So comment down for concave lens and convex lens, which will be the sign of, what will be the sign of our magnification. And hence we have one more topic left. Wait. Power of lens. This is a very important topic, power of lens. So we know lens converges the rays. So the power of our lens to converge the rays at a point, if our lens converges those rays at this focal length, it will have different power. If it converges those rays at this far focal length, it will have different power. And its formula is just 1 by f, which is our focal length. That is it. Its units are diopter. This power topic is very important for your numericals, and it will have the same sign as the focal length. For concave lens, our focal length is negative, so power will be negative. For convex lens, our focal length is positive, so our power will be positive. And hence we are done with our rapid revision of our chapter light. This is it for numerical. You should start after this rapid revision. I urge you to start practicing the numericals. I already have one video on numericals on how to solve it. I've solved almost all the PYQs and important questions in that video, so go check that out. And also join our WhatsApp channel, where you will get notifications of the videos so that you don't miss any. Do not just play Diwali all the time. Take some time out to also revise for your pre-boards. I don't want you to regret that you celebrated Diwali too much. So join the channel, get the notifications, and also I urge you to subscribe our channel so that you don't miss any videos. Hit the notification bell, and we'll come back to you with more rapid revisions of all the subjects. So till then, tata, bye bye.